Hello everyone, I'm Electrical Systems Technology. Today, let's take a look at a European-style transformer with a capacity of 90 kVA. Here is the high voltage cabinet, which is protected by a 638 composite switch. Next to it is the cable connection cabinet, which is equipped with a freezer because it is the incoming line, making it more convenient for cable connection. This is the transformer section, which houses a 90 kV oil-filled transformer. This European-style transformer is used in a small sewage treatment plant and is equipped with a 3-red-30 red label, which goes to the underground cabinet. In total, there are only 2 cabinets in the low voltage cabinet section. Despite having 2 cabinets, the incoming line cabinet contains the metering and compensation sections, as well as the entire phase change, heating and lighting circuits. Due to the working location of this photo being approximately 4,000 meters above sea level, all the circuit breakers have been treated with anti-thunder devices. The chosen circuit breaker is a 400 adjunct breaker. The outgoing line cabinet section also has 2 parts. It has a dual power supply circuit with the standby power supply coming from the generator and entering the outgoing switch. There are a total of 4 outgoing switches, 2 of which are used as backups. Now we are testing the monitoring circuit of the test instrument and the indicator circuit of the indicator light to see if its functions are normal. The indicator and monitoring circuits of the outgoing cabinet are all normal. Let's take a look at the lighting circuit on the border of the incoming line cabinet and the circuit with the fan installed. Right? The electric closing and opening switches in the incoming line cabinet are also working normally. Let's also test the electric wind and foot on the high voltage cabinet side. Everything is completely fine. Let's take a look. And most of the control circuits and secondary circuits have no issues. Next, we will explore 3-phase 10 kV with this transformer to test the insulation of the high voltage cabinet. Everyone take a look. The main bus bar on this side is now carrying a bidirectional high voltage of 10 kV. After the high voltage is active, the battery lock on this side cannot be opened because it is interlocked. It is achieved through a 380V input on this side, and then transformed into 3-phase 10 kV through the transformer. Now the capacitor, incoming cabinet, bus bar, and outgoing cabinet on the low voltage side are all energized, simulating a working state under normal energization. We have sealed off all the isolating switches, and next we can test the indication of the current meter in the outgoing circuit with the car pilot. We won't go into detail on the video on this side. Alright, that's it for this video. If you like my video, please give it a thumbs up and follow me. Thank you.